So, Docker. Why am I giving this talk? Developer time is really, really expensive. Docker's a great tool that can really help you have good local development experience, and it can really make things fast local development. But there's quite a few things that are the recommended way of doing things in Docker that I think just don't make that much sense and take up quite a bit of developer time. So this talk is to explain what we've encountered and how to avoid those. First problem is not using Docker. The last place I worked used Vagrant for a really complicated setup. Doing a Vagrant down, Vagrant up took over half an hour. So if one of my colleagues came to me and said, Dan, I need your help, can you check out this branch and help me debug something? The answer would be no. Unless I'm going to take like an hour out of my day, I just didn't have the time to check out a different branch and do Vagrant down and up. Docker usually takes about 10 seconds to go down and takes about 20 seconds to come up once all the layers have been built. So it's really convenient for just switching between different branches. I'm a big believer in having all of the tools that you use in development available to developers straight after they've checked the code out of the repository. I spent quite a bit of time trying to get Webpack to be fast enough to run inside a Docker container, and in the end we just had to give up. At least on OS X, the file system for Docker running, or a container running inside Docker, file system's just too slow to allow Webpack to really do its thing. It takes about 4 times longer to build JavaScript through Webpack inside a Docker container, which means that all the front-end developers had to install Webpack through Brew, which hilariously breaks sometimes, including like today, where we have to like delete everything from scratch and just like reinstall everything, and it works because why not? But yeah, the file system is quite slow still, so Webpack is something that needs to be running outside of the container. And we had quite a few fun and games with the Docker networking. Theoretically, when Docker spins up, all the containers inside it get a network name that all the other containers can use, and that works most of the time. But just randomly, sometimes we found that it would just break, and just restarting the containers would fix it. There's another problem as well. Is that means that if you use the internal Docker network names for connecting from like the PHP box to the database, that means that you can't use the same configuration outside of the container because the Docker network name only exists inside of the network. What we found to be way, way, way more reliable and easier to work with is to set up a loopback address on the host machine. So this is like 127.0.0.1. It's a network address that just goes back to the same machine, but instead of being just local to the single machine, which is what 127.0.0.1 does, there's a script written by a guy called Ralph Schindler that allows you to set up a loopback address that's accessible from outside the Docker container and also from inside it. That works, which is nice, but also it allows you to have the same configuration file for running code inside the container as outside, which means that if I want to just like debug why something's working, I can just run a script locally using the same config file that's being used inside the container. Really small one. This should be like at the top of the list of instructions on how to set up a Docker file. If you set WORKDIR, it will take you to that directory whenever you SSH into the box, which means you don't need to navigate it each time you go into the box. Just saves like 10 seconds every time I do that, but that's like 10 times a day, so a little time-saving tip. Another thing that this is a mistake on our behalf. Basically, Docker containers can inherit from one another. So you like have a base PHP box that you define one set of rules of how it's made, and then you have like a front-end PHP box and a background task managing PHP box. Theoretically, that's a good idea. In practice, we found that Docker Compose it runs into circular dependency problems where you've got to delete all your boxes and just build them all again and then run them, rather than just just being able to use them. The Docker files are so simple to maintain, there's just no point trying to have a base image that you inherit from. Just copy the text that's in the Docker files around, and if you ever need to update like the PHP version, it means that you've got to change 7.2 to 7.3 in 3 text files rather than 1, but that's a good 2 minutes of work. Well, we lost loads of time just like, why is this box not just coming up? The exception to that rule is Xdebug. Xdebug is a great tool. It does slow PHP down quite a bit though, and has some weird interactions with certain extensions. So most people avoid having Xdebug running all the time. It's nice having a separate container that inherits from your main PHP container that does have Xdebug enabled. So my typical workflow is I'll be working against the PHP container that doesn't have Xdebug on it. I'll hit a bug that would be easier to fix with stepping through it using Xdebug, and I'll just put in port 8001, which is the container that's running PHP with Xdebug, and it's just there, ready and waiting for me to use it. So I'll put my slides online as soon as I remember how to deploy my website. Long story. But like, this is the complete contents of the Docker file for Xdebug. It just inherits from the PHP backend box, installs Xdebug, and sets up the Xdebug ini file. And if you've got the loopback address set up, one of the things that's nice is that you can use the same IP address for all machines. It's good that you can use that because the remote connecting back that Xdebug normally doesn't work inside a Docker container, which, yeah, it's disappointing. Okay. So, if you talk to any people that work for the Docker company, or most people who are into containers, they'll say that one container should have one process running in it. I disagree with that statement. So normally, or what the Docker people recommend, is that you set up Nginx in one container and you set up PHP in a second container and have them talk to each other. So the downsides to this are, first of all, you've got twice as many containers to monitor. Even if just having the list of things running in your on your server, having twice as many is a bad thing. There's another nasty thing as well, is that when you actually have these running, this Nginx container needs to know about the network address of this PHP box to be able to talk to it, which means that you need to be able to inject that network name dynamically when the container comes up. There's just not, as far as I can see, if anybody disagrees, I'd like to know the reasons why. You can just put them both in the same container. There's a script that absolutely no one can read the URL of, which I might tweet around later, that shows just a simple bash script that says how to run Nginx and other things at the same time in a container. It's like 20 lines of code, not that difficult. And that allows other small nice things like being able to use the local file system for sending large files through Nginx. Another thing that caught us out, very, very small things. Set up your domain names like this, where the first part is the environment, and then the rest of it is the actual box name, and not box type or box name, and then environment in the middle. If you do it the environment first, it means you can set up wildcard domains, so just star.api.foobar.com, and the box itself doesn't care about it. Otherwise, because wildcards can only be at the start in Nginx, otherwise you have to hardcode them all by hand. And hilariously, we found out in the last week that Google Chrome doesn't understand the concept of changing parts in the middle, and it will happily remember passwords from your production system to your development system and vice versa, which is not always a good thing. Okay, another this is actually a big thing that we did wrong, but it doesn't sound big, is that for various reasons we put the config files for actually building the live servers in a separate repository than the source code and the code for actually building the containers. There were good reasons to do that, but it had a really nasty downside in that when a developer wants to see what config is going to be used for a server, it means that they can't just look at the project that they're working in. They need to go off and look at another repository and try and find the relevant files. And because they were generated using a thing called Helm, it means that they can't even just like go in and read it. They need to like figure out where's the actual file being generated from. I strongly recommend just putting both your development and production config files into the same repository where the source code and containers are, and then just choose between the two of them, between like the development and production version, using an environment flag, obviously defaulting to production probably. And if you're really adventurous, generate the config files on the fly when the containers boot up. At least having the source for them in the same repository will make life easier when you're like trying to figure out, do we need to increase the file size limit for PHP or something like that, rather than having to like search around. And I really do mean all the config files in source control. Don't use any of the files from /etc. Most of the time they'll have sensible defaults in there, but when you set up containers, just copy all the files out of whichever version of PHP you're using from where they get installed by default, put them under your own source control, and then from then on you don't need to worry if when we upgrade from PHP 7.2 to PHP 7.3, are there going to be some things that we've missed from the default config files. You've got them all under source control. Upgrading version of PHP is not going to change them magically. They're just there and work. And another thing that the Docker and Kubernetes community are trying to encourage is both Docker and Kubernetes have tools for running multiple processes and like scaling processes up, and they'll try and get you to use those tools. Supervisor's still really good at this. A, it still works. B, it's still really simple, and you don't need to learn a whole new load of technology to use it. But more than anything else, Supervisor D will work in local development with just Docker Compose. A lot of the supervisor replacements that Kubernetes people recommend require you to effectively run Kubernetes locally, which is something to avoid as far as I understand it. I've not done it myself, but the reason for that is that everybody I've talked to have said that it's a complete horror story. And final thing, I think, is copying all project files into a container is the way to go. So by default, or most people have a project laid out like this. They'll have a source, public, and then Docker directories, and they'll put the different Docker files for different containers under a directory. By default, when you build a Docker container with a Docker file here, it only has access to the files underneath this directory, and you have to manually copy them all in by hand. This just seems to be a waste of time for most PHP projects. For Docker Compose, you can just put a volumes and then put that's ./var/www, which copies all the files from the current directory into the container. And if you're building containers separately from Docker Compose, this tiny little dot at the end specifies a build context, which says this is the container that I'm building should be able to access the files from underneath this location. We optimized one of our containers for space by only copying in certain files and not all the project files, and then we realized that actually we did want to access some of the code that was in a different directory that we hadn't copied in the first time around, and it was a bit of a nightmare because it then means we need to change the whole file system for the container rather than just having them all there from scratch. That possibly doesn't apply to some people in the room who are running hundreds and hundreds of containers where file size really does matter. But if you're running less than 10 or say, just including all the files by default is a lot easier. And that's it.